Hello, here's the question number 19. It's also a good one. It says a perfectly conducting square frame of mass m, length, side length is L, and inductance L, capital L, with a small gap cut in one of its arms is placed on a frictionless horizontal floor where uniform magnetic field is given by this. Here, K is a positive constant. Center frame initially coincide with the coordinate system origin as shown in this figure. If the gap is closed, that means circuit is now completed, and with a perfectly conductive material, so there's no resistance coming in. Frame is imparted a velocity v0 along the positive x direction without any rotation. How will its displacement x vary over the time? So that's a three-dimensional picture, so that's planar thing, and that's going to be vertical story, so y direction is there. Now this is center has initial coordinates 0 0 0, then after you will be shifting like somewhere here, so let's say center has been shifted by displacement x. So you'll find this coil, which is a square coil. This square coil is going to have magnetic field dependent on x, because magnetic field depends on x, so you will find the flux passing through this square coil is going to be dependent on x. So let's find the flux through this frame. Flux is going to like b into dA, and then integration. Now b is like b naught 1 plus kx towards plus y direction, and when we take any strips, so it will be like dx along the x direction, and this z direction is going to be L, so L dx, that's area, differential area. Now limits at any when the center reaches to x location, then you'll find this front edge will have a location as x plus L by 2, and the rear will be having location as x minus L by 2. So integration goes from x minus L by 2 to x plus L by 2. Now you can easily integrate this. V0 L is constant, you can take it outside. 1 becomes x and kx becomes kx squared by 2 in this initial and final limit. When you place this initial and final limit for this, then you'll find this minus this will become basically equal to L. And when we place this initial and final limit on x square, so this square minus this square, so we can apply a plus b, a minus b stuff, which will be like 2x into L, so that comes with 2x into L, and there will be k by 2 as a factor. So this simplifies to this 2 getting cancelled out, so like b naught L, the one L can be taken outside, so b naught L is square within bracket 1 plus kx. So this is the flux that will pass through this square coil frame, or frame you can call. And when this center is located at x distance on this zx plane. Now since this phi is a function of x, so we can say that this phi depends on x, so we can find this d phi by dt, which is induced EMF. When you differentiate it, you will find like b naught L square, 1 will become 0, k is k, then dx by dt. Dx by dt is going to indicate the velocity of this frame along the x direction. So the induced EMF could be written as like b naught L square kv, where v is the velocity in the x direction, right? Now, since this is moving, so this frame will behave like a circuit too, because there's going to be inductance as per the question, no resistance because perfectly conducting, and there's going to be EMF coming because this is EMF we have calculated. Now, using this Kirchhoff's Loops law, we can find E is equal to L di by dt, where E is b naught L square k into V, and this is going to be like L di by dt. From here, we can find di, which is going to be like b naught L square k by L V dt. Now this v dt is nothing but dx. Again, we can integrate from 0 to I, 0 to x. Now 0 to I is 0, initial current will be 0 in the circuit, and then finally let's say I when the displacement is x. Initial displacement of the center was 0. Now this comes out, or this gives us this I is equal to b naught L square k by L into x. This is the current. That means current will depend on the location of the center of the frame. Now, since there is a current running on this frame now, then you'll find there's going to be force acting. You will find these two, the sides of this square, which is parallel to x-axis, will have a zero net force because their force will get cancelled out. However, the sides which are parallel to z-axis will be located at different x locations. Due to there will be different magnetic fields, and you'll find there's going to be difference in the force. And you like force, if this is increasing, when we are moving it to the rightwards, flux is increasing, so current will be in such a way so that it tries to decrease the flux. So that means there is going to be a retarding force in nutshell. So net retarding force on the frame is going to be like F is equal to ILB, B of the location where x plus L by 2 is coordinate, minus ILB of the B of the location where x minus L by 2 is the coordinate. So IL we can take common, and these two magnetic field can be found out using the formula of magnetic field, which will be like B naught 1 plus k into x, which is x plus L by 2, minus B naught 1 plus k into x, which is x minus L by 2. This could be simplified because B naught is getting cancelled out, and then for kx will get cancelled out. What will left as KL by 2 plus KL by 2, that is KL, and this is going to be B naught. So F turn out to be IL B naught KL. So now I can be substituted from here, and you find like B naught L into K from L square into K. So B naught L square into K, that will whole square, that is ultimately B naught square L raised by 4 K square. And there's going to be x by L as well, so x by L. Now this retarding force, the force that was acting toward x equal to 0, is proportional to displacement. So that means it says like this force is proportional to x as well as opposite direction. And so this is the condition for the simple harmonic motion. Now from here we can write this x must be equal to a sine omega t. Why sine? Because at t equal to 0, x was 0, so it has to be a sine omega t. That means in a sine omega t plus phi, phi must be 0. Now to find this omega for this omega, this is going to behave like k equivalent. So divide by mass, so that becomes omega square. Take under root, that becomes omega. So like B naught L square K divided by under root ml. So that's omega. Now this is the maximum displacement of the center from this x equal to O location or 0 location. So we can say there's going to be mechanical energy conservation and half K factor A square. This must be equal to half m v naught square. This v naught was the velocity at this thing at the mean positions, or we can simply say this v naught must be a omega. So a must be v naught by omega. Omega we already know, v naught is given to us, so a can be calculated. Now this x became a, which is v naught by omega. Omega is this number, so it's like v naught under root ml divided by b naught L square K. Thus a amplitude maximum displacement into sine omega t, where omega is again b naught L square K divided by under root ml into t. So this is the location of the center of frame, or the displacement of this frame at any time as a function of time. So that's our final response. Thank you.